Okay, so Google and parallel universes. Everyone's talking about it. It's pretty wild. I mean, who wouldn't be fascinated by that?
Right.
So, we're diving into this article from Futurism.
Okay.
It's Google says it appears to have accessed parallel universes.
Catchy title.
Yeah. Let's see what's really going on here.
Well, it'd be easy to just brush this off as science fiction, right?
Yeah.
But what makes this so interesting is that Google is actually basing their claims on results they got from their new quantum chip
Okay.
called Willow.
Right. And this isn't just any other chip. It's crazy fast.
Yeah.
Like this article says it did a task in less than 5 minutes.
Wow.
That a supercomputer would need septillions of years to do.
That's a lot of years.
It's like a number with 24 zeros. Like, it's just mind-boggling.
Yeah.
What could we even do with that kind of power?
That's the big question.
Yeah.
Well, Hartmut Neven, he's the founder of Google Quantum AI. He was quoted as saying this speed lends credence to the notion that quantum computation occurs in many parallel universes.
Whoa, okay.
That's a pretty bold statement.
Yeah.
And it directly connects to physicist David Deutsch's multiverse hypothesis.
So is Google saying that their chip is somehow working across multiple universes to get these speeds?
It kind of seems that way.
That's insane.
Yeah. But, and the article mentions this too, there's a lot of people who don't buy it.
Yeah, of course. I mean, it's a pretty out there claim.
Yeah, and physicist Sabine Hossenfelder, she's one of the most prominent voices pushing back against this.
Okay.
Her argument is that, well, yeah, the calculation that Willow did was complex. It didn't really have a practical application. It was basically just a show of speed.
So, like, it's like having a rocket that can go at the speed of light.
Yeah.
But nowhere to go.
Pretty much, yeah.
Okay.
Hossenfelder also questions how much Google's relying on this idea of quantum entanglement to support their claims. And just as a reminder, that's that phenomenon where two quantum particles are linked and whatever happens to one instantly affects the other, even if they're miles apart.
Yeah. It's spooky action at a distance.
Exactly. So Google suggests that this entanglement is evidence of their chip interacting with parallel universes. But Hossenfelder's not convinced.
You know, this isn't the first time Google has made a big splash in quantum computing, right?
You're right.
Didn't they make that quantum supremacy announcement a few years back?
Yeah, back in 2019.
Yeah, that caused quite a stir, too.
Yeah, they claimed they'd achieved quantum supremacy because they did a calculation that a classical computer couldn't do in any reasonable amount of time.
Okay.
But, and this is interesting, that claim was challenged by IBM.
Oh, right. They're big in the quantum computing field, too.
Huge player.
Okay.
Yeah.
So what was IBM's problem with that? Did they think Google was faking their results or something?
No, not really. Their argument was that Google's definition of quantum supremacy was too narrow, and they said that that task that Google had done could actually be done on a classical computer. It'd just take a lot longer, like 2.5 days.
Oh, okay. So not like septillions of years.
But IBM's challenge started a whole debate about what quantum supremacy actually means.
Yeah.
And how to actually accurately compare the power of quantum and classical computers.
So it sounds like there's a lot of healthy competition in the world of quantum computing.
Oh, absolutely.
Different companies all wanting to be on top.
Yeah, and it's important to remember that we're still in the very early stages of this technology. There's a lot we still don't know. And even the experts disagree on how to interpret the results we're seeing.
Okay, so we've got this incredible speed, mind-blowing entanglement claims about parallel universes.
Yeah.
And a lot of debate.
A lot of debate.
So where do we go from here? Is there like another way to understand all of this without jumping into the multiverse?
There is. The article mentions the Copenhagen interpretation. That offers a different perspective on how quantum particles behave.
I'm all ears.
Okay, great.
Let's explore that and see how it fits into all of this.
Okay, sounds good. Well, the Copenhagen interpretation says that quantum particles exist in all possible states at once.
Okay.
Until we try to measure them.
Okay, so it's in this blurry state of potential until we look at it, and then it has to choose a reality.
That's basically the idea.
Okay.
It's a very different way of looking at things compared to that multiverse theory.
Yeah.
Right? Instead of every possibility branching off into a separate universe, the particle kind of collapses into a single state when we measure it.
Right.
And that's what we perceive as reality.
So does that mean then that this Copenhagen interpretation would suggest that Google's chip isn't actually interacting with parallel universes?
Exactly. It gives us another way to explain the behavior we're seeing.
Okay.
And the thing is, we don't really have a way to definitively prove or disprove either interpretation.
Right.
Not yet, anyway.
So not yet. So we're stuck with these two fascinating,
Yeah.
but very different ways of understanding what's going on.
Yeah, it's pretty mind-blowing.
At this quantum level.
Yeah.
And it sounds like we need to be careful about jumping to conclusions.
I think so.
Especially about something as crazy as parallel universes.
Yes, I agree. And the scientific community is still debating these really fundamental questions.
Yeah.
New discoveries could totally change what we think we understand.
At any time.
Yeah.
You mentioned IBM earlier.
Yes.
And how they challenged Google's 2019 quantum supremacy claim.
Yeah.
Could you tell me more about IBM's approach to all of this?
Sure.
Are they just trying to rain on Google's parade?
I don't think so.
Or do they have a different vision?
I think it's more about making sure that we have a really accurate understanding of what quantum computing can do.
Okay.
And IBM is a huge player in this.
Right.
They're not backing down from the challenge at all.
So what are they doing? What's their approach?
Well, what's interesting is that they're really focused on developing quantum algorithms that can actually solve practical problems.
Okay.
Problems that classical computers just can't handle.
Even with like massive optimizations and stuff.
Right.
Okay. What kind of problems are we talking about?
So they see huge potential in things like drug discovery.
Oh, wow.
Material science, financial modeling.
Okay.
All these fields where complex calculations and simulations are super important.
Yeah.
And where quantum computers could really change the game.
It makes sense. So Google is pushing the boundaries of speed.
Yes.
Exploring this mind-boggling idea of the multiverse.
Right.
And IBM is kind of urging caution.
Yeah.
But also focusing on how we can actually use this.
Yeah.
It's like two sides of the same coin.
That's a great way to put it. It's a very dynamic field.
Yeah.
Full of healthy competition and different perspectives.
Yeah.
It's important to understand both approaches to really get the big picture.
So much to think about.
There is...
You know, I can imagine some of our listeners might be feeling a little lost.
Yeah.
With all the technical stuff.
It is complicated.
And the complex theories.
Yeah, for sure.
What would you say is the key takeaway for someone who's just trying to understand all of this?
Well, I think the most important thing is to realize that quantum computing isn't some far-off fantasy anymore.
Right.
It's here.
It's happening.
It's happening now, and it's developing so fast.
Yeah.
It's going to impact all our lives in huge ways.
Yeah, this isn't just for scientists and tech people anymore.
It's for everyone.
So what can we do? How do we stay informed? How do we stay engaged?
I'd say just keep exploring. Read articles like the one you sent in.
Mm-hmm.
Don't be afraid to ask questions. Quantum computing is complex, but the more we learn, the better prepared we'll be for all the changes it's going to bring.
I like that. We're all on this journey of discovery together.
Exactly.
Speaking of discovery, I want to go back to something we talked about earlier, the different ways of understanding quantum mechanics. We talked about the Copenhagen interpretation.
Yeah.
But I think it's worth taking a closer look to really understand this debate.
It's an important one.
So let's break down the Copenhagen interpretation a little more and see how it challenges what we think we know about reality.
Yeah, let's do that.
What are the key principles behind it?
Well, the Copenhagen interpretation, like I mentioned, was developed way back in the 1920s.
Okay.
And it basically says that. It basically says that quantum particles exist in this fuzzy state of possibility, what we call a superposition, until we try to measure them.
Right. So it's like they're in all these states at once.
Yeah.
And then by measuring them, we force them to pick one reality.
That's a good way to put it, yeah. The act of observing or measuring it causes this collapse of the superposition into just one state. And that's the reality that we see.
So how is this different then from Deutsch's multiverse theory?
Right.
They both seem to be dealing with this idea of lots of possibilities existing all at the same time.
Yeah, you've got it. They both deal with that weirdness of quantum mechanics.
Yeah.
Where things can be in multiple states at once.
Yeah.
But the multiverse theory takes that a step further.
Okay.
Instead of the superposition collapsing into one reality when we measure it,
right.
It says that every single possibility actually plays out in a separate universe.
Whoa. Okay, so let's say we've got a quantum particle that can spin up or spin down.
Okay.
In the Copenhagen interpretation, it's doing both.
Right.
Until we measure it, and then it has to choose one. But in the multiverse theory, there's one universe where it's spinning up, and another where it's spinning down, and they both exist at the same time.
Exactly. And according to Deutsch, that's what quantum computers are doing.
Okay.
Tapping into all these parallel universes to do their calculations.
Wow. Okay, my head is spinning a little, but...
It's tough to wrap your head around.
But I think I'm starting to see the difference. But if both of these interpretations are trying to explain the same thing...
Right.
How do we know which one is right?
That's the big question, isn't it?
Yeah.
And we don't have a definite answer.
Okay.
At least not yet. There's no experimental evidence that definitively proves or disproves either one.
So it's still a mystery.
Yeah, they're both incredibly compelling ideas.
Yeah.
And they both have strengths and weaknesses.
So then how can we confidently say if Google's claims about accessing parallel universes are true or not?
That's a great point, and it shows how important it is to think critically and be skeptical.
Right.
When we hear scientific claims, especially ones that are really pushing the boundaries of what we understand.
Absolutely.
Yeah.
So as we wrap up our deep dive today into Google's claims, the different ways of understanding quantum mechanics and the future of this amazing technology.
Absolutely.
What would you say is the most important thing for our listeners to remember?
I think the big takeaway is this. We're at the very beginning of a scientific revolution.
It's pretty incredible.
Quantum computing is still so young.
Yeah.
But it has incredible potential, and we're just beginning to understand what it all means.
It's exciting, it's challenging.
It is.
And it really makes you question everything you thought you knew.
Absolutely.
About reality.
That's sure.
So stay curious, everyone.
Yeah.
Keep exploring and engage in these conversations.
It's important.
The future of quantum computing is being shaped right now.
It is.
And we're all a part of that.
We are.
Well, thanks for joining us on this deep dive.
It's been a pleasure.
Who knows what amazing discoveries are waiting for us out there in the quantum realm.
I can't wait to find out.
Keep those curious minds engaged, everyone.